Welcome to Walk About the Galaxy, the crude astronomy podcast, where the science is universal, the opinions are personal, and the calculated risk for loss of podcasters is less than 1 in 270. We are strange charm atop the astroquarks, also known as Josh Caldwell,
Addie Dove,
and Jim Cooney,
coming to you from the Walkabout Studios in my porch.
Hooray!
A donation to the UCF Foundation will get you a sweet Walkabout t-shirt so you can show off your excellent and discerning taste and also help keep the podcast going. Our stumpers today are stylistic.
Okay.
Jim,
yeah,
and this ties in, it's not only stylistic, but it's also timely.
Perfect.
Related to current events and space news. Jim, NASA meatball or NASA worm?
What?
Tread lightly.
NASA meatball or NASA worm? And these are not foods.
No.
What? Well, worms are good for fishing, so NASA worm. I don't really either. I don't know what either one of those things
What?
are.
Really?
I have no
Really?
idea what you're talking about.
You're fired.
You're fine.
I mean, like, what are they? I don't know.
Those are the NASA logos.
The,
Oh.
The meatball is the
right.
canonical blue with the swoosh through it. That's the NASA meatball.
stars.
They've actually been painting the NASA meatball on the vehicle assembly building.
they've been painting it?
Yeah, they've been refreshing it.
Like
today.
Repainting it.
Yeah,
Okay.
repainting it, yeah.
Okay. So I thought it was
And
on
then
there.
the worm is the NASA, like in the curvy letters.
Right. I don't like that one. I like the meatball.
Yeah, I'm a meatball person too,
You
even
would
though I'm a
be.
vegetarian. But
Vegetarian meatballs can be delicious.
they are, yeah. But it's one of these things where there's like these cycles of fashion
Right.
that are sort of generational. So
Mm-hmm.
the original NASA logo is the meatball, right?
No. Yeah. Sorry.
Yeah. And so that's like from the 60s and the era of Apollo and everything. And then sort of shuttle era came along and they created the worm logo, which at that time period, the 80s, was very sort of futuristic looking, fancy, curvy font.
It's also
Right.
much more simplistic, right?
It's
like
very-
so like to have that on something is much easier than the pretty complicated meatball logo.
Right.
Right.
Yeah. And the meatball has that sort of old school kind of 50s B movie look to it almost. And the worm has this very stylized computer graphic kind of Tron look to it. And then, of course, the worm got this big backlash from people who loved Apollo and Mercury and Gemini. And so
It was
this-
officially discontinued in 91 or 92 or something.
Which, the worm?
The worm.
Yeah. So they're like, okay, we're going back to the meatball. And everybody's like, yeah. But now it's a new generation. And so now they're like, we're going back to the worm, and Addie's generation is all like, yeah.
It's actually a little bit before my generation, but I like the worm. I like the stylistic look of it. I had a shirt when I was younger. I've been trying to find it. I know I have a worm shirt somewhere.
So if you had to get a tattoo of one of them, it would be?
Neither.
You must.
Yeah, no, I'm
There's
saying
no
I'm going
choice.
to tattattoo you.
If I ever, I got a specific, if I had a tattoo of either, it would, I guess it would probably just be the swoosh part, actually, of the NASA.
swoosh is cool.
The NASA with the swoosh.
The meatball is definitely more complicated. Anyway, the reason that we're bringing that up is related to Addie's stumper, which I'll just go ahead and give them and talk about it.
Perfect.
Addie, space shuttle flight suits or SpaceX flight suits.
Not really a stumper, it turns out. I really don't like the SpaceX flight suits. So I'm going to go with shuttle, I guess.
The shuttle ones are the orange. Is that what you're thinking of? Yeah.
Yeah. So they had the pumpkin pressure suits that they wore on shuttle. I mean, so the whole thing with all the SpaceX stuff, it's very futuristic, but it's sort of like 50s futuristic, right? So it's it's very, even with, we've talked about Starship aesthetics before, and with the bridge,
the crew access
arm to the capsule, and a lot of the stuff in the interior of the capsule, and then with the suits, it's very I've heard it described as Jetsons for the suits,
right?
And it's very almost robotic looking, but also just sort of ill-fitting, and
It's almost look like they're trying to look futuristic rather than actually being a practical thing.
And it's what view of futuristic is it? And
yeah. I just like, are they pressure suits? Because it just looks like a shirt or something.
It doesn't look like there's. I mean, they must.
Maybe
be.
there's a pressure suit underneath it, I guess. But
Yeah.
it looks like I just want to go up and put a belt on those guys.
Yeah, it doesn't. It doesn't. Yeah, maybe that's part of it. It's also it doesn't look super robust to me.
Yeah.
But I'm sure it's fine.
And I am known for my fashion sense.
Yes.
But they're much more like the worm. Those spacesuits are much more simplistic,
They also have the worm on them.
and they have the worm logo on them. And of course, we are recording this on the eve of the second attempt, or second launch opportunity, I should say, for Demo 2,
Yes.
which would be the first crewed space flight of the Crew Dragon on the Falcon 9. We'll talk about that, as well as rivers and liquid erosion on Saturn's moon Titan.
Ooh.
Amazing pictures of a possible baby planet forming around another star. New odd developments in the Earth's magnetic field. But first, this episode of Walkabout the Galaxy is brought to you by Dunder Mifflin, assistant to the regional manager Scranton branch, Dwight Schrute.
Oh.
Nice.
Bears beats Walkabout the Galaxy. Fact: through simple brain power, I can will myself to have the same knowledge as an astroquark. People assume that telescopes are necessary to unlock the mysteries of the cosmos. False. I live on a farm and have seen 3 sheep work in formation to force a goat to eat the grass stuck on a pig's behind. Mystery unlocked. No telescope required. Though I did use night vision goggles, skills I bring to my position as a volunteer sheriff deputy on permanent leave, which means all my sting operations are undercover because they are not officially sanctioned, even though I have been sanctioned. Top that, astroquarks. I started listening to Walkabout the Galaxy because I thought it was training for an outback stargazing hike in Australia where I plan to find workers to care for my sheep. But Walkabout the Galaxy is not about that. I'm not sure what it's about. Dwight Schrute. Australians wouldn't give a XXXX for anything else.
Huh.
Wow. Thanks, Dwight Schrute.
Is that a tagline for something?
It is a tagline for something.
You're getting real
Obscure.
Obscure with the taglines. It's getting very difficult.
Yeah.
I've never been to Australia, so I don't know.
Marmite.
What kind of... Yeah,
That's-
Vegemite.
That's a
Vegemite.
reasonable guess. It's Australian consumable.
Fosters.
And that's closer.
These are
Yeah,
the-
it's a
these are
kind
the
of beer.
Australian things
Shrimp.
I know.
It's a kind of beer.
Okay.
It's Castlemaine XXXX beer.
I don't know that
Oh.
beer.
I don't know how they say the XXXX part. Maybe they say
Triple X?
XXXX, but
Probably triple X.
it's quadruple X.
Quadruple
You
X.
weren't
4X. I wasn't counting.
4X beer.
4 times.
So, anywho,
Anyway.
Demo 2. So tell us about the space news, Addie, because there's a lot of it. You've been on the front lines. You've been interviewed on the
have.
news,
Yeah.
the radio, TV, all of the media. And now
Most of the media.
we're interviewing you
Yes.
on Walkabout the Galaxy. Tell us about what is going on with Demo Mission 2. Is that what it's called?
Just Demo 2.
Demo 2.
Yeah. Yeah, the next one is called, is the first mission, right?
Mission 1.
It's called Mission 1
or something like that.
Crew 1. I forget what it's called. Anyway, yeah. So Demo 2, I think we've talked about it a
yes.
decent amount, but it's happening. It's actually happening. Maybe Florida weather is notoriously anti launches oftentimes, and so it's been some pretty crappy weather.
It's kind of unfortunate that the launch windows seem to be in the afternoon, which is not a good time in the Florida in the summer to
Yeah,
try
Exactly.
and launch
they
a rocket.
migrate
Yeah.
over time, but right now they're in the middle of the afternoon in the summer in Central Florida, which is just like begging
When
for
we had
trouble.
a tropical storm
That
off-
just-
that was
right.
forming. Yeah, so the first launch attempt was Wednesday, and they actually were pretty close to being able to launch, but I think there was some lightning violations right before, and it's an instantaneous window right now, which means they only have like the launch time to launch.
Right.
And so they called it about 15 minutes ahead because it was like, oh, we violated weather.
Right.
And it's partly the launching weather, and it's partly also the downrange weather, because if they abort, which this vehicle can do, is it has little rockets that can pull the capsule away from the main rocket and abort, they have to go downrange. And you have to have weather that's appropriate to be able to like splash down in the ocean safely downrange also. And you don't want to do that in a tropical storm,
Right.
for
Right.
instance.
Just like even like wave height limitations and stuff like
Yeah.
that.
All sorts
downrange.
of there's
For the downrange
the
stuff.
list of criteria that it makes it astonishing that it ever is possible to
Right,
launch the
yeah.
thing.
Yeah.
But one of the like you were mentioning that they call it ahead of time. First, it's instantaneous, so there's no launch window. The good news about that is, 'cause I've been to launches
Yeah.
where there's a 2-hour launch window,
And-
and they delay
then it
for
doesn't go.
the whole freaking 2 hours. And they're like, no.
Yep.
At least this time, once it's called, and
Yeah.
you're good. But
Then you just have a 2-hour drive back.
yeah, some of the 2-hour drive that's normally 40 minutes or
Yeah.
something. Some of the criteria, like we cannot have this happen within 15 minutes of the launch.
Yep.
So if that happens 15 minutes before, then also at least you don't need to wait the next 15 minutes. You're like,
Yeah.
not going to happen.
So they just
not
called it.
possible.
Yeah.
Right.
They were saying that if it had been like a 10-minute window, even they probably
They
would have
might
been
have been able to go.
But it was one of these things where it was just like tons of clouds and lightning around, and
So why is it an instantaneous launch window for this and it isn't for other things? What determines
So
what's a launch window?
so it has to do with the launch vehicle itself. So some vehicles have like extra propellant basically, and they're able to. So it has to do with the fact that there's a specific time that you have to launch the vehicle from the Earth so that it can be in the correct orbit to rendezvous with the space station, right? And so all of that is some pretty complicated orbital dynamics. And some of the vehicles have enough basically like extra fuel that they can change their orbit once they're up there. But that we've talked about that, right? It takes a lot of energy to change your orbit. Currently, the way the procedures are designed, the way the fuel is done with the SpaceX Falcon 9, they cannot change. They don't have enough leeway
Enough
to
Delta
do that.
V, as we say in the biz.
So it has to do with something with the Delta V, something with the timing sequence of when it gets loaded and like how long the fuel is good for, basically. Then
Also, yeah.
and then if they can get to the station.
Part of the difficulty with space station is it's on a very inclined orbit, so that its orbit goes north enough to include the latitude where the Russian rockets launch from. So it's on a more inclined orbit, which makes it harder for us coming from Florida to get to it. And then frequently, like if you're launching a communications satellite, you just need it in the right circle. But if you're rendezvousing with a space station, you need it in the right circle and at the right point on that circle where the stupid space station is.
Stupid
So
space
it
So
makes
how this was something that Beauty Cork and I were discussing after this because we didn't
Who was, Beauty, sorry.
Beauty Cork, Astro Cork,
Beauty Quark, who's in the audience today.
She is in the live studio audience today. I mean, it takes about 90 minutes for the International Space Station to orbit the Earth one time.
By the way, Beauty, when you're not here, Jim calls you bottom. Just,
I was cognizant of the fact that she is 6
that's why
feet
I
away
was
from me
like,
currently.
I'm like, Beauty, who's that? Oh, you mean bottom.
Oh,
Oops.
Sorry.
It's okay. She doesn't listen to the podcast, but when she's here, yeah. But yeah, it orbits every 90 minutes, so it can't change its, the path that it's on that much every time it orbits. It just slowly changes.
What are you talking about?
So
why?
what I'm saying is, why if I can launch at 3:30, can I not launch again at 5?
Because it's
because
not
it's-
the same
it's-
orbit every time.
Because the Earth is rotating underneath it.
yeah.
Right.
And
But-
the station orbit isn't exactly the same orbit, right? It's at a different
If you look at the ground tracks of the space station,
Yeah. It's just
it
does it-
processes.
it's like a ball of yarn
Right.
that wraps around.
Right, but
So
but it doesn't seem like it could change that much in one orbit. But I guess maybe the
It's
fact
the
that we
Earth-
have rotated.
We've rotated 90
by-
minutes worth,
yeah.
15 degrees.
Okay,
So
that'll
the-
put the latitude of the
And that's why Saturday's launch opportunity is not
is an hour different
at
from the-
exactly the same time. And so
Okay.
those things drift.
Yeah, it's at like 3:30
Instead of 4:30.
3:20
Yeah.
on Saturday.
Yeah.
3:33. That's what I saw. 3:33
All right,
Eastern.
and so, Addie, you're going back to be to expert commentate again.
Yep.
And Trop and Beauty, are you going to the coast?
No, we went on Wednesday to go find the tallest building around that we could find and get on the top and watch it from
Space Mountain.
roughly the University of Central Florida location. So we'll probably do that again on Saturday. But
Yeah.
it was. I mean, it seemed like traffic was an absolute mess.
So there's definitely, even though the rocket itself is a rocket that we in Central Florida have seen take off
This was my
literally
argument to
dozens
bottom. Excuse me, beauty cork. Was that she was kind of fired up and wanted to go all the way down there, and I was like, "This is just it's
a Falcon
visually it's
9.
going to look like all the other ones that
No,
we see."
you can
so.
tell that there are humans on it.
from looking at
you
it.
can
From
see them
looking at
waving
it.
from the.
You can tell by the way it is.
Yeah, but
But it has excited a lot
Sure.
more interest in people. So there were big crowds there to see the launch. There was other launch news this past weekend of a less happy sort. Not that Demo 2 news is happy or unhappy. It's just upcoming. But Launcher 1, which is a vehicle
Oh,
near
yeah.
and dear to our hearts because it's going to be carrying our CubeSat up into space, they had their first powered test flight. First time they ignited they're an air.
So this is Virgin
launched.
Orbit. It's a big airplane called Cosmic Girl that drops a little rocket from under its wing, and the rocket's supposed to get to orbit then.
Right. So they drop it at like 35,000 feet from this big 747, and they dropped it, and the engine ignited, and it started
About 9
taking off, and
seconds.
it started, heading upwards towards space, and then it stopped.
Yes.
The
Stopped.
rocket didn't stop, but the motor stopped.
oh, it just
It
stopped. It didn't blow up.
auto-terminated. It didn't blow up, actually.
did not blow
It
up.
fell in the ocean,
Yeah.
Okay.
So,
but they don't recover it.
But yeah, so they're analyzing data to figure out what went wrong with that. But they've got several more in the pipeline, so we'll be anxiously and eagerly keeping an eye
Yeah.
on developments from Virgin Orbit to see their next.
And then today,
Opportunity.
SpaceX was testing their Starship SN4 prototype in
Serial
Boca
number
Chica,
4.
Texas, which is the one I think that had successfully test
done a
fired
hop.
before.
Okay.
I don't know if it had hopped, but this
Okay.
is just the big thing that it's the big silo-looking thing. Anyway, it blew up.
So it did actually explode.
It went explode.
Was this now? They've had failures with the
No,
Starship
it went
from
explode.
like pressures thing before.
There was a
but
big boom.
This was the fuel
Big
ignited.
fireball.
Okay.
Yeah.
Yikes.
Oh.
Yeah.
So-
But the rocket that's going to take the Perseverance rover to Mars is at the Cape and is vertical in the facility.
And that's not a SpaceX rocket.
No, it's a ULA rocket, I think.
Yes.
Yes.
Atlas.
An Atlas 5. Yes.
Perseverance, as you said,
Perseverance.
also known as Percy,
Percy.
informally, is the roughly speaking a copy of the Curiosity rover,
It's like slightly upgraded.
more or less. Curiosity rover went in 2010, and Percy is launching this year, and it arrives on Mars in February of 2021. And it's one of its main missions is to like go find an interesting bit of Mars
And then stash it.
and put it in a little can.
Percy's just a little hoarder.
It's got a coffee can or something.
Yeah.
It's gonna
stash away
put
and then
some
sit
dirt in
there.
and put the top on it and set it on top of a rock for some future mission to pick up and launch back to the Earth or something, right?
Yep.
That's weird.
It is a little.
Yeah,
weird.
I mean,
It's
it
weird
was
that you couldn't-
originally designed when they had this whole plan of another follow-up mission, but then they decided to go ahead and cache something anyway and just hope that someday it
Oh.
would be.
So there's no actual plan to go get it?
Not
That's
yet.
just- okay.
They're like, we've
There's
had a
a-
lot of
there-
Mars missions at this point.
Right. There's only a notional plan to go get it.
Yeah.
Yeah. So, any other space news?
Probably, but I've been pretty swept up in this other Demo 2 stuff.
Okay. So, our science topics today, we have, for starters, a new paper about Titan, Saturn's largest moon, and
Jim loves Titan.
by a whisker.
You could fly!
You could fly.
You could fly. I also
like
thought
Peter
that.
Pan.
Mm-hmm.
And by a whisker, it is the not quite the largest moon in the solar system. They originally thought it was because it has this thick atmosphere that would let Jim fly
It's
around
tricksy.
with his cardboard wings.
Yes, yes.
Some future date.
Yes.
But it's a little bit smaller than Jupiter's moon Ganymede. Nevertheless, it's a planet-sized object.
Yeah.
Has this atmosphere, and Cassini, of course, observed it a lot and saw a bunch of interesting features on it: lakes, sand dunes made of like frozen hydrocarbon granules. The lakes, of course, are not water.
No,
It's liquid
they're
methane.
Way
liquid
too cold
methane.
out there. Yeah.
And not a lot of craters, though. And so,
But some.
some.
But it's sort of like, I mean, it's sort of like the Earth in a lot of ways, right? It has sort of weathering processes where the weathering is from like liquid methane and ethane instead of water falling from the sky. And actually, a lot of the rocks are made of icy water. But it does, so it has that thick atmosphere to protect it, just like the Earth, where we don't find a lot of craters either.
And there's a new study where they've found a grand total of like 90 possible craters.
Ooh.
And which is, compared to something like the moon or even Mars, is not very interesting. And they're trying to understand why are there so few? Why do they look so run down? On Earth, there are very few craters because you've got wind and rain and life, of course.
And volcanism and tectonics and all these things. Plate moves around and erases them, so you got all kind of things. So there's some of that on Titan. We don't expect there's tectonics, plate tectonics and stuff, but it does rain,
Yeah.
but just not water.
Right. So these hydrocarbons, this is natural gas, basically, as a liquid that is raining, and that rain funnels into lakes, and it can rain anywhere, so the precipitation could erode some of these craters, and then these tributaries into the lakes can spill over and potentially erode some of the crater rims. So previously it had been thought that most of the erosion of these craters was due to wind, but the wind is super calm, turns out, on Titan.
Even
Just a
though
good thing. It's cold enough. You don't need a brisk wind.
Step outside, it's like, it's a brisk, it's 200 degrees below zero, but at least it's calm.
The wind
Do you
chill
have-
isn't so bad.
Did you have your SpaceX suit on?
The wind chill is also only 200 degrees below zero, so yeah.
Yeah, one of the challenging things with these observations too, right, is that it's got to be all radar data. So it's radar data from Cassini, which is sort of complicated to interpret because it's not just like, a lot of times when we look at craters on other planets, we see either color differences, basically, right, like visible albedo differences, or we get topography maps and we can actually see vertical elevation differences. But that's challenging. Interpreting radar data is always challenging. So you can sort of see like how rough the craters are, maybe some height differences, but there's a lot of interpretation that has to go into that. So
Yeah.
it's a challenging data set to work with.
Yeah, with visual also you get shadows because the sun is over here and the camera's over there.
So you can do stereo
So you have
imaging and
shadows, and you can look at different
And
times
for
of day
the
so that the shadows
listeners,
move around.
Josh put his two hands on different sides
different
of his
places.
head.
I use the word here and there
Yes.
to indicate.
Near?
But with radar, the camera and the light are the same.
Yes.
So you don't have the shadow unless you do this other. They did
Complicated.
this more complicated things where they use the Earth as one of the radar antennas, but also you have to be super close to get it. So they get these sort of spaghetti noodle strips along the surface of the moon, so you don't get global coverage. So that's challenging. They only were able to get topographic information on 14 of these 90 potential craters to get heights of the rims. But the bottom line is that Titan's craters are more rundown than the craters on the icy moons of Jupiter. And it seems that is due more to, at least for the rims, to some liquid erosion of these liquid hydrocarbons washing over these rims and eroding them, as well as these icy granules of hydrocarbons filling in the bottoms of the craters.
So, question. I don't know the answer to this. So on
Great.
Titan,
False.
it rains.
True.
Ethane, methane. Or methane, ethane.
Oh, no.
For our British listeners. We on Earth, it's kind of cool. We live in just the right temperature thing where sometimes it rains and sometimes it snows.
Pours.
Does it
Oh.
Yeah.
snow ethane and methane on Titan?
Ooh, interesting. I don't know what the
Does
like.
Titan have
Well,
significant
I don't know how-
seasonal difference, or is there enough temperature difference across the span of
So-
the globe?
The lakes are only in the polar regions. So we don't see lakes in the equatorial regions of Titan. And I think we primarily see them in the winter pole. So there may be a sort of seasonal aspect where it's too cold for them to be lakey Sorry, it's
Too
too
warm.
warm for them to be lakey in the
Yeah.
in the polar summer, and it needs to be in that long polar winter to get those lakes.
Yeah, because you have to have really cold temperatures to get liquid methane.
Right.
So I guess it would be ludicrously cold to get solid methane. So
Yeah.
it wouldn't do that probably.
I think
Well,
so.
yeah. I mean, it'll be. Then
don't
you have
remember
to
what
look
the
at what
phase diagram
what
looks
the
like.
temperature is with altitude as you go up, and how
Right.
high the clouds are that are precipitating it,
Right.
and what the temperature is up there. So it's going to be colder up there, but I don't know. I'm afraid I don't know these answers off the top of my head.
Okay.
I should
then
know
what
this.
else? This. I'm not paying attention to the science. I'm just wondering things like, what would be colder? Standing nude, of course, on the
Of
surface
course.
of Titan, or standing nude.
Say it again.
In nude in Antarctica in the middle of the winter, because sometimes in Antarctica it gets to near 100 degrees below zero Fahrenheit, and the winds approach 100 miles an hour.
Let me. Yeah.
Quite the wind chill
Oh,
if
so
you're in the
asking,
nude.
You're asking whether the wind chill is colder in Antarctica
Yeah.
or on Titan?
Yeah.
Because you've got 100-mile-an-hour wind and 100 degrees below zero, and a 0-mile-an-hour wind and 200 degrees below zero,
That's what I'm
whatever.
wondering. Which one would kill you faster?
I'm going to go with Titan.
Titan.
Yeah, I'm pretty
Probably.
sure that your skin, you will freeze in an instant. Freeze dried.
Wear your parka.
Yes.
Yeah.
Cover up
On
before you go
Titan's, on
out.
Titan's travel poster,
Make
it
sure
says,
you
wear
cover
your parka.
cover
Yeah.
up. Don't forget your oxygen.
Don't go out
Right.
in the nude.
Yes.
Don't go out nude.
Probably,
Okay.
probably
Lesson learned.
not advised. Well, our trivia is Titan related, and it has to do with these lakes.
Okay.
We mentioned it has a lot of lakes.
It does.
And so what we're going to do, it's a new style of trivia. It's called mix and match.
Ooh.
Okay. All right.
So I'm going to give you 3 lakes, 1 on Titan and 2 on the Earth,
Okay.
and then 3 sizes
Oh,
and
it's already
3
too
depths.
complicated.
And you've got to figure out which size
Do
and
we get
which
a piece of
depth
paper?
goes with which one. No, but you do have a computer in front of you, and Jim's got a cell phone. So you
I'm a
can write
genius.
things down.
I don't need it.
You can,
Great.
can remember. So you'll get the general idea. We'll come back have the numbers for your answers. I was going to say guesses, but of course
we
you don't
We
need to
don't
guess
guess.
these. So the largest lake on Titan is called Kraken Mare,
Yeah,
which
it
is an
is.
awesome name.
That is
Yeah, it is.
fantastic.
Yes. Most of the others have very unawesome names. In fact, I think all of the others have unawesome names. They're just the names of lakes on the earth.
Yeah.
But
That's
they
so-
say Lacus
Kraken. Release
instead
the
of
Kraken.
But Kraken Mare is the largest
Also a
one
good
on
rum.
Titan. And then we're going to compare it
Okay.
to Lake Superior
I've
here
heard
in the United
this before.
States and the Caspian Sea,
Mm-hmm.
which is the largest landlocked body of water on planet Earth.
True.
Correct.
Oh, I was hoping you were going to go with Lake Baikal, the deepest lake on Earth.
Where is that and how deep is it?
It's in Russia, and it's 6,000 feet or something like that. It's very deep.
Okay. I'm using, we're, of course, going to be using SI units, Jim. So a couple thousand meters
Fair
or
enough,
something
yeah.
like that. Yeah.
Yeah.
No, I'm not going to the deepest
Okay.
lake.
All right,
I'm going
Caspian
to
Sea. I
the
like it.
Caspian Sea,
Okay.
which is the largest landlocked body of water on Earth. It's somewhat
Going for
salty,
breadth, not depth.
Right.
but it's less salty than the oceans.
And
Makes sense.
Yeah. So your areas are going to be in square kilometers.
obviously.
The 3 areas in ascending order are 82,000 square kilometers, 386,000 square kilometers, or 400,000 square kilometers.
okay.
And your depths, also in meters, are 160, 406, or 1,000.
I feel like Jim's
And
gonna do
those are
better
the
at this one.
deepest points of each respective body of water or methane, ethane, methane, ethane, not average depths. Okay. So
Roger.
we'll come back and see what you think about how big Kraken Mare is and how it stacks up to Lake Superior and the Caspian Sea.
Stay on the edge of your seat, listeners.
Yes. So moving out into the galaxy to a star far, far away, 500 and some light years away.
It's not that
A, B, or Rigay?
far. Yep.
There's this amazing picture.
There's a little baby picture.
Are we going to post it?
Yes.
Yes.
Excellent.
Yes. This will be the picture for this episode, which, by the way, is episode, do you know what number we're on?
42.
False.
199.
198. So we're coming up on a big 200. We'll have some
Wow.
special things
Some
planned for the
giveaways.
Maybe we
200th
can get some
episode.
fireworks for that one.
So AB Aurigae in the constellation Aurigae is a young, hot star, and it's got this big swirly disk of gas and dust around it. And Hubble took pictures of it years and years ago. And ALMA, which is this new big array of millimeter sort of far infrared telescopes, has been able to take some super detailed pictures of it. And it looks like there's a little kink.
The newest pictures are from the Very
Something-
Large Telescope.
Right.
The SPHERE instrument on the Very Large Telescope, where SPHERE is an acronym, I think.
I'm sure it is. And there's a little kink in the
Kinky.
swirl that they are interpreting as the site of a planet forming. And the kink is about the same distance from that star that Neptune is from our sun. And everything I read about it, nothing ever had an arrow pointing to the kink, but I think I know what they're trying. They always just say it's the really yellow part. Well, the whole picture is yellow, right? Because they've done it in false color and it's just a yellow. So the really yellow part I'm taking as the brightest part.
Yeah.
And it looks to me like these things that occur in Saturn's rings.
Right, that's what I was going to say. Is that like you find masses in these things by the mass's effect on its surroundings. That's exactly what you do with the rings.
Right.
You've spent
also
decades looking at kinks in the rings and
Right.
ripples in the rings.
And in Saturn's rings, we call these kinks propellers. It's a little thing, and then you've got the ring material going along, and then it takes a little hiccup, and it goes on a different path on the other side. And in the middle, we say, well, there must be some massive thing there. And so this looks like, I think, the full-blown version of what in the Saturn's rings, which we call our sort of local laboratory for planet formation, a propeller object.
Yeah, it also looks like, it looks like the simulations we have of these things, too, in a lot of ways, right? So, like, often we do simulations that show the density of the disk and where the dust is in numerical computer simulations, and they're often false color like this,
Right.
too, right? And
Yes.
so they look very similar. It's pretty cool.
Yeah, the picture looks so amazing that you would think, oh, that is a computer simulation. Maybe it's just so much more exquisite detail than we've been able to get.
That's one of the really beautiful parts about science is when those computer simulations match the actual data so beautifully. You're on the right path. And
Yeah.
Thanks
plugging
for
the
saying
right
that
things
in the
into
correct
your-
way, Jim.
What's that?
Thanks for saying that in the correct way.
To say that the computer simulations
Match
matches
the
the
data,
data,
yeah.
instead
Right.
of that the data.
Yeah.
Let me go find an observation that agrees with my computer model.
Yeah.
I'll throw out all the ones that don't. Right.
Yeah, it's super cool. A little baby planet.
So that's exciting to sort of maybe be seeing the dynamics of the disk that's feeding material, because that kink in that image is material feeding into a planet that's forming there about the same, like where Neptune is in our solar system. And of course, we're always like, we saw it with Hubble, but not in this close. Then ALMA and the Very Large Telescope have now seen in much closer, and they're building in South America the...
Extremely large telescope.
What are they going to call it, the one after the extremely large?
Ludicrously large telescope.
It's like the Tesla's...
Ludicrous mode?
Ludicrous, because they had modes before ludicrous mode,
They did.
right? What were they called? There's insane mode.
Insane mode.
But ludicrous is above insane,
It
right?
is.
So maybe after extremely large telescope, there'll be the insanely large telescope.
Yeah.
That would be so awesome if they make an insanely large telescope and then a ludicrously large
Yes.
telescope. I almost wish I had, enough. Well, I definitely do wish I had it. I don't almost wish I had enough money to make such a telescope. I do wish I had enough
Not
money
sure
to
you would
make
actually
telescope.
make that telescope if you
Right.
had that
Yeah.
money, but
Right, yeah. So the extremely large telescope, 37 meters, I think.
39.
39
Even
meters.
larger than the TMT,
The 30-meter
the 30
telescope.
meter telescope.
Under some uncertain future in Hawaii.
Yeah.
The importance for there's several ways for having multiple telescopes, but a big one is in the southern part of the planet, you can only see
southern
a certain
sky.
part of the sky, and so you can't see things that you can see with a telescope in the northern part. But that extremely large telescope is supposed to open in 2025
Cool. After we put humans on the moon
again.
again
Right.
in the
Because
current era.
we did put humans on the moon
After
50 years ago.
So you say? No, I'm just kidding. We're not going to go there.
I was alive then. I bear witness. So that will provide even more amazing pictures. Maybe we'll see other things going on inside. And there's a whole bunch of stuff we don't know about how planets form and also how they move around. And this kinky stuff with the swirling thing in this cool picture shows the interactions of the planet with the disk, which is what pushes the planet around as it sort of migrates in and out, and what leads to some of these crazy exoplanets that have been discovered, hot
Yeah.
Jupiters and things.
And there's lots of other structure that you can see in the pictures that they have. So like there's definitely this one sort of structure that shows a planet forming, but there's probably other planets that would form also in that system. And it's,
Right, all sorts of stuff is going on,
Yeah. And it's a pretty young star, so we'd expect it to be probably in this planet forming stage.
Right. Speaking of planets, Earth.
Oh, that's the best one. That's our home.
It is. I have to say, it's still my favorite planet.
Yeah.
Even,
For now.
even though we're
We're doing our
There's
best.
some-
We're
We're
doing our best.
there are
to
some
ruin it.
issues, but
It is a
still-
good planet. And one of the things that makes it a
You
good
can
planet.
go outside in the nude.
Yes, you can go outside in the nude.
A lot of places.
apparently
routinely
Jim
do.
does all the time.
I do. Just to test how fast I'm going to die, right?
Steps
Turns out in
outside.
Florida,
The
it takes a
neighbors,
while.
the neighbor's like,
Oh,
Cooney,
that's time of day
get
again.
back inside. He's like, I'm just making sure I'm not freezing to death.
That's right. I'm doing a scientific experiment. Let me be. But one of the things that makes our planet so cool and unique, not unique, but nice for life is our magnetic field.
Yay.
Our magnetic field does all kinds of things for us. It deflects charged particles flowing in from the sun and so forth. So we spend a long time studying and trying to understand the nature of our magnetic field. And we've talked about it before, of course, on the podcast, but it's very complicated. And it's one of those surprising things that, given all of the stuff that we study, you'd think we'd understand the origin of our magnetic field well, but we don't.
It's funny that we can do things like we've talked about how we know how many stars there are in the whole frickin' universe.
Right.
And things
Yeah,
like
but I'm
that.
not sure where how our magnetic
but
field
the magnetic
comes to be.
field that's generated right underneath our feet, we're like not
Yeah.
sure how that's exactly working.
Right. I mean, we have, a general idea, that the core has kind of this liquidy outer layer that flows around, and it has something to do with that, but it's a really complicated system, and the specifics of how that system produced the magnetic field we see, very complicated. And the magnetic field we see is complicated. We've talked about it's kind of like a bar magnet where there's a big North Pole and a South Pole, but they move around. They're not exactly opposite one another on the globe.
And you say, use the expression colloquially, the magnetic field that we see. Of course, we can't actually see it.
Right.
Which is one of the reasons why it's hard to figure out what the heck is going on.
Right.
You have to go into it and take a measurement. It's like
can't-
temperature.
Have
Right.
we ever tried going into space and just sprinkling some iron filings?
Oh,
Yeah.
that's totally what we should do.
Well, see, here's the thing. I'm gonna rant for just a second.
Yay.
Oh,
Jim rant,
Rant
to
time.
top rant.
No, seriously, the instrument. So we were going to be talking today about a cool. I mean, not for very long, but just as a fun thing. Quickly, there's a cool anomaly in the magnetic field that's over the South Atlantic Ocean called the South Atlantic Anomaly.
clever.
Something like
Makes
that.
sense.
Yeah. But the way that this is being mapped out is by a suite of instruments called SWARM.
3 spacecraft.
This is what pisses me off.
Yes.
It's 3.
And it's
When I
called-
saw this, I didn't know about Swarm before this. I mean, I was aware
'cause
that it
it's a-
existed, but I hadn't looked into the details of it. I assumed if you're going to name the thing Swarm, there's dozens or hundreds or thousands of these. There's friggin' 3. You can't name a suite of 3 satellites.
Yes.
Oh,
a
I thought,
swarm.
It
That's
I thought-
ludicrous.
I thought you were mad that it was 3 because that wasn't enough to get really good measurements.
no,
but
no,
you're
no.
just
It's
mad
not
fine
even-
that it's
Swarm.
3, but you call it
You
a
don't-
triad
You
or
call
something.
You call it few.
Yeah.
Few.
Triple.
The far Earth widget.
Yeah, you call it. The swarm is preposterous for 3.
Yes. When I
There
saw
it
that,
is.
I'm like, oh, okay, you've got one, a couple, and
A
swarm.
Yeah.
Is swarm an acronym?
It must
Doesn't
be.
matter, but if you're forcing an acronym to be swarm, There's something
Yeah.
wrong with you. It's wrong. Anyway, I'll get off. Okay, so that's
You're done.
So,
I'm
so,
done.
so Swarm
rant.
is a mission of 3 spacecraft. It's a European Space Agency mission.
right.
Yep.
And
It's a weird, some weird setup. Like 2 of them are pretty close to one another, and the other one's far away. I don't know. It's a weird thing, but they're measuring.
Yeah, there's 2 that are in a pretty similar orbit, and then one that's in like a almost 90 degrees.
Right.
Oh,
And I'm
off
sure
orbit.
that there. I mean, obviously, there are very good reasons for this. They intentionally
Yeah.
put those in those orbits, and it works reasonably well. But don't call it swarm. But but anyway, yeah. So we're finding that this this South Atlantic anomaly is kind of growing and changing. It's maybe separating into 2 bits and stuff.
So what is the South Atlantic anomaly?
Well, you tell me.
Okay, it's a region of the Earth's magnetic field where the magnetic field is a little bit weaker,
Right.
which means it's a little bit easier for charged particles from the sun to get closer to the Earth.
Yep.
And Addie and I, since we fly spacecraft all the time,
All the time.
that's one of the things we have to pay attention to is will the spacecraft run into any problems when it flies through the South Atlantic anomaly?
And that's more common if you have polar orbits,
Right.
Because they're more likely to fly over that anomaly. If you have an
Yeah.
equatorial orbit, if you're like further north, or
Yeah.
just you can stay out of that.
You're just
region.
never crossed that region. It's called the South Atlantic anomaly, but it's really the South American anomaly.
It's sorta like
kind
the
of
Bermuda Triangle.
over the
It's-
southern third or something like that of South America. So it's
Yeah.
not way down by the poles, but it isn't not near the equator either.
And it's also really
Part
more
of it's over the ocean, but
also it has been
It's
moving.
migrating,
Yeah,
right?
yeah.
So,
It has moved toward South America from the southern western Atlantic
Yeah.
Ocean. And, we've talked previously about how weird the Earth's magnetic field. The Earth's magnetic pole has also been moving. It's now actually moved from the western hemisphere into the eastern hemisphere. It's crossed the international date line. It was way, way down in Canada.
yeah.
Yeah.
20, 30 years ago, and it's
Yeah.
been racing at 50 or 60 kilometers a year
trying to
towards
GTFO.
Siberia.
Nah.
And it's crossed the international date line, and they had to do, actually, it's moved so much. Every 10 years is the sort of schedule where they sort of update the Earth's magnetic field model.
Yeah, but
And-
it's important for when you're doing satellite predictions
And also, like,
Earth-based predictions
even some
and-
cell phone nav
Yeah.
tools,
Yeah,
they
yeah,
use
yeah.
GPS, but they also use this magnetic field model of the Earth. They did an exceptional update of it in 2019, 1 year early, because the thing has changed
Yeah.
so quickly. And things are getting weaker. The South Atlantic anomaly seems to be splitting
Right.
into 2 anomalies, and is also getting more anomalous, meaning the magnetic field's getting weaker there.
Yeah.
Yeah.
So,
So
is
this a harbinger of
It's all
a
a sign.
flipped magnetic field?
when I was a kid, I thought harbinger was misspelling of harbinger.
What?
That's
not a word.
I know.
Yeah.
I didn't understand the word.
Right.
And
Fair enough.
harbinger, I thought it was
It
harbinger.
seems like it should be bringer.
Something
'cause
that's
it is
bringing the har.
Yeah.
Right.
Bringing
It's
the har. That sounds fun, though. Har, har, har.
It's like, oh, here's the,
that bad
it's
comedian.
a storm that's a harbinger. It's bringing some har about bad weather to come. So
Yep.
anyway, it does seem to be a harbinger. Anyway, I've always had a grudge against that word.
You think
So
it
if
should have an
against
extra R in
swarms,
it?
again. Yeah.
it
I'll
does.
keep my words smaller
So-
for you.
It does
What
get
are
me excited. Gets me excited about the Earth's magnetic field flipping.
Right. Which would be
Flipping
I mean,
out.
it
Probably
flips.
terrible.
yeah. it would have a lot of
It's not great for
it's
like
not going to kill us all, but it's going to have a lot of
satellites.
consequences.
There's a lot of technology, it turns out, we have now that relies on not getting a lot of high energy charged particles on it,
Yep.
Yeah.
things like that.
Yep.
So, but it's pretty fascinating that we
It
can,
is.
yeah, that
And-
we can
and-
study this now. And like you mentioned, CubeSats, right? There's a lot of I've worked on a couple of proposals that have been to do like 6, for instance, CubeSats that look at the magnetic field and look at interactions for
Mini
space
swarm.
weather, which is like a mini swarm, exactly. And it would, but you need distributed measurements, right? You need spacecraft in slightly different orbits or in leading and trailing orbits, so you can get temporal resolution, so you can get
Right.
spatial resolution.
Because the magnetic
So-
field isn't constant in time.
No.
So you can't. It's very, very hard to measure the thing. You've got to have a bunch of
And a spacecraft isn't just like
measurers.
sitting there taking a measurement. It's
Right.
orbiting, right? It's going around and around. And so as it's taking a measurement, it's moving at 17,000 or whatever miles per hour. So like
It's
it's hard.
It's
Yeah, very
complicated.
hard.
It is
Yeah.
I keep adding R's to things. Complicated.
Yeah, harbinger. It's a harbinger of my dementia. It's bringing some har. Yeah. All right. So Titan and its lakes, or Kraken Mare. So got Kraken Mare, Lake Superior, and the Caspian Sea. Let's start with area. So here are your three areas: 82,000 square kilometers, 386,000 square kilometers, and 400,000 square kilometers. Which goes with which?
Those are all areas.
You want to guess first? Or
No.
shall I think 400,000 is Kraken, 300 whatever is Caspian Sea, and the small one is Superior.
What do you say, Addie?
I think Caspian is the largest, and then Kraken, and then Superior.
So those two numbers are very close. Jim is right. Of course, I gave away that Caspian can't be the smallest number because I already said it was bigger than
You
Lake Superior.
did say
'cause it
that.
was- although I said largest landlocked, I guess we
That's
could
true.
imagine that Lake Superior, which is in the middle of the North American continent, is not
I
landlocked.
could imagine that.
But yes, Kraken Mare is about the same size, slightly larger than the Caspian Sea, although it's got a more contorted shoreline, and it's sort of cut in half by a narrow throttle that's about as wide as the Straits of Gibraltar, with half on either side. These lakes on Titan, by the way, very minimal. Like we're able, with those radar measurements we were talking about earlier, able to see that the wave, you can like measure wave heights on
Yeah.
them.
Right.
The wave heights are like a centimeter,
Right,
or
very
so,
small, right, yeah.
or half an inch or so.
Which that must be one of the things that indicates there's very little wind, right? I mean,
Yes.
or
Yeah.
at least it corresponds
Yeah.
to there being.
Although
very
it turns
little
out waves are super complicated too.
They are.
They
but
are,
like
but
Ralph
they're
Lorenz
often
has done a
wave-driven.
bunch of like
or wind driven.
wave measurements with liquid methane type thing. I remember back in
Yeah.
the day. Did some to figure out how strong the winds could be to make those waves. That
But
we
people
see.
have a hard time even understanding like why the waves on the deep ocean of the Earth are the way they are, just from a basic physics standpoint.
Waves,
It's one
how
of
do
these
they
things
work?
like
Seems so simple, but
Jim
yet-
does. Jim does the easy stuff like cosmology. If you want to solve some
It's
hard,
so much easier than
do
those
you want to do
things,
some
it
hard
really is.
stuff? Explain waves.
Explain
Yeah.
waves.
Okay, maximum depths. You've got 160 meters, 406 meters, and 1,000 meters. Maximum measured
106, 4,
160,
160.
406, and
406.
1,000 meters.
1,000 is the maximum depth of those three.
And which body of liquid does that depth go with?
Superior.
The
Jim?
1,000.
Yeah.
I also think it's superior, although one of the reasons I thought the other one was 400,000 was because it's round numbers, and we're not going to know the depth of the lake on Titan to any kind of specific number. So for that reason, I'm going to switch it up and say 1,000 is the one on Titan.
Okay.
Oh.
And then I'm going to say the smallest one is the lake on Titan, and the middle one is the Caspian.
And
And I'll
what
say
about-
the smallest one is Caspian, the next one is Superior, and then the deepest one is
Okay.
Okay.
Titan.
I think Addie got at least one right, and Jim was 0 for 3.
it's like mastermind.
The Caspian Sea is 1,000 meters at its deepest point. Lake Superior at its deepest point, 406 meters deep. And the deepest measured point on Kraken Mare is 160 meters, and that's measured precisely because we're measuring it by shooting a radar beam through it and measuring the light travel time of the echo off the bottom.
Yeah,
And
that surprises
So
me.
I think I
thought
just
Also,
got
with
Titan
Kraken,
right.
with Kraken Mare, we also have a pretty accurate measurement of the area because we've got good imagery of the whole thing.
Yeah.
Even in that said, that's not bad sort of psychoanalysis of the of the question. But yeah, Kraken Mare is larger than any lake on planet Earth, but not so deep. At least of the points that we've measured, and it's probably not got any.
So its volume
great
is not
hidden
nearly
depths.
as big as
Right.
the Caspian Sea, for
Right.
example.
People were, I think, surprised that it was measured to be as deep as 160 meters, even.
Yeah, there's a bunch of images of like the changing shorelines, and those show relatively shallow shores.
Right.
Interesting.
Yeah.
I think I just got Titan right then. I think I switched.
I think you got Titan right, but the other two flipped, and Jim was off
Let's
on
go
all
back
three.
to the tapes.
Yeah.
That's not a thing we do.
Well, while it may have felt like the time for an actual walkabout, it was just another episode of Walkabout the Galaxy. If you liked this episode of Walkabout the Galaxy, find someone who has 5 million followers and convince him or her to like Walkabout the Galaxy.
Yes, please.
Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag Walkabout the Galaxy. Our theme music was composed by Richard Jerusik. Production assistance is provided by Diego Rodriguez. Jillian Gloria is Director of Marketing. Thanks to our listeners in Virginia and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the astroquarks signing off until the next episode of Walkabout the Galaxy.
Go Crew Dragon.